When given an atom, we have it dissected like this, right? And then it has different labels: the nucleus, the atoms, the electron shells, and all that. So when you have an atom like this, and then you we can identify various things around by the period of the atom, the period to which it belongs, the group it belongs, and then we can also get the block, right? So what do I mean by the block and all that? Okay, so I had a first model of the atom periodic table. We have this periodic table first, right? We'll be using this. So if you go like this is period one. Things like this are in period two. Things like this are in period three. Things in this lane are also in period four. So everything here is in period four, period three, period two, period one. So right, these are the period. When we are looking at it horizontally, right? So, and the groups are, when we are looking at them vertically, this is group 1 up to group 18, right? So, we explained this in some section some time ago. So, we have period 7, we have period 8. So, we said that how do you identify the period that an element belongs to? The period tells you the number of shells, right? So the period tells you the number of shells. So period one have only one shell, period two have two shells, three shells, and four shells. So the atom that I showed you earlier, right? This atom, so you can tell the number of shells that it has. It has this one, two, three shells. So this belongs to period three. So the period of this group is period three, right? Now the group of the atom, right? The group that it belongs to, that's the vertical component, the group that it belongs to, is determined by the number of valence electrons. So this means that you have to identify the valence shell, meaning that the shell with the highest shell, the greatest shell, you have to look at that, or the outermost shell. That's the valence shell. You look at that and then you count the number of electrons on it. The number of electrons on the valence shell will tell you the group that it belongs to, right? So if you go to this place, right, we can see that the valence shell is shell 3, and that's the outermost shell, or the biggest shell here, the blue, the largest one, right? So we focus on this shell, and then you count the number of electrons. You have 1, 2, 3. So that's going to be group 3. So that's group 3, right? And now the next thing is the block. So let's go period and group, period and group. So period 3, group 3, that's which element? Let's go and then identify them. That's on the periodic table. So we have shell 3, group 3, right? So that's aluminum. So this one comes like this, and this one comes like this. So this particular element is actually aluminum. So we'll be able to use the period and the group to identify the elements, right? Yeah. So which block does it belong to? Now, what do I mean by the block? Blocks are this stuff, right? This is the full periodic table. This is the full periodic table, right? And then we have this to be the P block. We have this to be the S block. The hydrogen is also belonging to the S block, right? So, and then we have um the middle guys here that are the D block. So we have the S block, D block, P block, and we have the lanthanide. This lanthanide and actinide series, they form the F block. How do you mean by what do you mean by that? You see that S, D, P, F. Do you remember them? This when we were doing electronic configuration, S, P, D, F, right? They are referred to the electronic configuration. So you cannot tell the block directly from just the atoms, right? So in this section, we'll be given electronic configuration. That's the question that come mostly, right? This particular way of doing things is from junior high school, but then senior high school, they will give you electronic configuration, and then from the electronic configuration, you should be able to find the period, group, and block, right? Okay, so we know the blocks that exist. We have the S block, P block, D block, and then F block. Those are the blocks that exist. How do you know something belongs to the F block? But let's start everything from this so we have this electronic configuration, right? So I'm going to have to find the group. No, let me start from the period. So the period, let me start from the period. We need to find the period, we need to find the group, and then we need to find the block that this particular can belong to, and maybe identify it. Okay, so we have, how do you find the period? For the period, we say that is the number of shells, right? But when we're having the other atom, we're counting the number of shells. But over here, the shells, right? The shell numbers are there. Okay, so we have 1, 2, 3, and 4. So you count among the shell number, right? Count the largest number of or among the shells. So this shell 1, this is, this 2 orbital belong to shell 2, this is shell 3, and then there's 4, so we shell 4. So the largest number, right, among the principal quantum numbers, that's the numbers here, right? That tells you the period of the element. So here it is going to be in period 4, because the largest principal quantum number is 4, right? Or the largest number of the shell is 4 over there. That tells you the period. Okay, now we need to go and focus on the group. Which group does it belong to? So when we're trying to find the group, we say that locate the greatest shell, the largest shell, and then count the number of electrons on that shell. So the same way, if you come here, the largest shell is shell 4, right? The largest shell is shell 4. So all the orbitals in shell 4 is going to be, we just have 4s1, right? That's the only four we are seeing here, because orbitals, like you see the 2s orbital, right? The second shell has 2s and 2p on it, 2s and 2p on it, right? So the total number of electrons on this second shell is going to be the total number of electrons from each of the orbitals. So S is having 2 and P is having 6. That will be 8 on the second shell. When we come to the 4s, right? The fourth shell. The fourth shell is just having, we are just having 4s1, right? And then the 1 is the number of electrons, as we said. The S is the orbital and 1 is the electron. So if we go to this fourth shell, the total number of electrons that we can find, that's just 1. That's the totally only one here at the top there, right? So the group number is the referring to, you have to refer to the number of valence electrons, right? So the valence shell is the shell 4, is the fourth shell, which is here, and then the number of electrons on that valence shell is just 1. So that will tell you that this is in group 1. Which block does it belong to? Now, on that valence shell, we have to find where the last electron will enter. When you are filling the electronic configuration, right, on the valence shell again, the last electron, when we are filling it using the methods that we learned, the last electron has entered into um an S block. So the S block is the one holding the last electron. So all electrons are being filled from here to here, but the last one, the very last one on the valence shell, is entering an S orbital. Since it is entering an S orbital, this particular block belongs to the S block. So this is an S block element. So let's try to identify the element itself. So we go to our table, right? Our table of blocks. This one, let me clean it to make it nicer a bit. So we know where the S block and P block and all that are. So what did we have? Four as the, so the S block, we had an S block. So the thing belongs to an S block. That's what we had, and it was in period 4. So period 1 is for this guy, period 2, period 3, and period 4. The thing is in period 4, right? The thing is in period 4, and then the group is in group 1, right? So that's calcium. So it's an S block element, and the S block was having 1 electron, right? And that 1 electron tells you the group. So the group number is 1. The group number is 1. So group 1 on the S block, that's potassium. So the particular element that we have is just potassium. So this is potassium, electronic configuration of potassium. Okay, let's go and solve another question. So this one too, let's try to find the period as usual. So what do you think the period will be? The period, you have to locate what's the greatest, the largest principal quantum number here. 1, 2, 3, 4. I can see 4. I can see 4. I can see 3. So but 4 is the largest number. So it's going to still be period 4. So period 4. Now what's the next thing? After the period, we need to find the group. So the period is the horizontal and the group is the vertical one. So the group, so you go to that period, right? You go to that shell. So I'm seeing 4 here and I'm seeing 4 here. So all the 4, right, they need to bring together their number of electrons. So they have 4s2 and 4p4, right? So it means that if the number of electrons that totally from the fourth shell is 6, so the group number is actually group 6. Is going to be group 6 from the fourth shell, right? So what is the last shell? So let me go to block. So the block, so on that fourth shell, where is the last? What do you think that probably the last electron will be filled? So 4s2 has come, then a 4p4 has come. It means that the last electron has actually entered into a p block. So this is a p block, this is a p block, the block is a p block, right? You find the element. Let's go and find the element again. So it's in period 4, but it belongs to a p block, right? This is the p block we said, and then that's going to be group 6. The thing is probably in this group 6. This is group 6 here, right? And then it is in the fourth shell. So is I'm falling on selenium. I'm seeing selenium over here as that element. So it's a p block element, right? Yeah. So that's it for this particular element as well. Okay, so let's solve another one. um Electronic configuration for this. So I'm going to try to find the period again. What do you think will be the period for this? So 1, 2, 3. So that's 3, because that's the largest principal quantum number. Now the next thing is you have to find the group. Which group does it belong to? You go to that 3 is a third shell, right? So you go to that the one with the largest principal quantum number. So on the third shell, right, it is the third shell here, right? So how many electrons are there? So the 3 is coming with s and 2, so only 2 electrons are inside. So you count the number of electrons on that shell, that is just 2. So and then the block definitely is obvious. Obvious that on the 3 the last electron is just on the third shell, is just from the s block. So you can, it's an s block, and it is in period 3, it's in group 2, and then an s block. So what we go is that we go to period 3. So period 1, 2, 3. 3, let me use another color, right? It says an s block, right? Yeah, it's an s block, so we need to stop around here. This is an s block stuff. And then how many electrons are there? 2 electrons. So since there are 2 electrons there, so we are going to be in group 2. So that's magnesium. Okay, so let's solve this one quickly, right? This one I will challenge you to go and find the element, right? So we are going to first focus on the period. So the period is period so 1, 2, I can see 2, 3, 4, 3, 4, 5. 5 is the largest principal quantum number, so it's period 5. And then which group? So on that period 5, so it's going to be 5s1. The 5 is bringing only one orbital, and that one orbital contains only one electron, so there's no need to sum from anywhere again. So that's a group 1. And then the period, the block, that the last electron is entering an s block, so it's an s. Fine, so use that to go and find the atom on the periodic table. This is the last one, right? I'm going to do how do we call this? Let me do period first. So for the period, you look for that element, right? So it's 4 and 3, 4 and 3, right? So that's what mean that 4 is here, 3 is here. So 4 is the largest one, so you group 4. Now the group, you have to be careful over here, right? Now the group is a total number of electrons on the valence shell, right? So let's say the valence shell is 4, right? 4, and then the number of electrons on the 4 is just coming from s, which is only 1, so we are just 1. And then the block, So just be careful that the block is where the last electron will enter. The last electron is entering what? So when we are filling the electron, remember, right? We fill the 4s2 before we fill the 3d10 or 3d5 or whatever. So here is 3d5. So when we are filling it at this thing, actually the last electron is actually entering the 3d, not the 4s, when you follow the concept that we learned, right? So the last, when we are filling it during the electron configuration, we come to 4a. We usually fill 4s before we fill the 3d. So the last electron will probably be entering into an 3d or a d orbital. So the block is actually a d block. It's a d block, right? A d block element. And then it's in period 4. It's in group 1, right? Group 1 of the of that particular period. Okay, so when we enter that side, let me clean this thing. um yes, so yes, so this is about the electronic configuration of this particular element. And then I hope that now if they give you questions around that, you'll be able to figure your way out and find the number of valence electrons, the valence shell, the valence whatever, and then the period as well, right? This is how to find all that from just the electronic configuration.